Okay guys, so in this video here, I'm going to show you how to be converting from decimal, so base 10, all the way up to hexadecimal, which is base 16. Now to give you a little bit of background here, decimal is base 10 because we represent it with the numbers 0 to 9. If you count all those, we have 10 symbols, so that means base 10. And generally I'm just going to put dec there for that. And then with hexadecimal, we have base 16. That means we have the symbols 0 to 9, but then we have 6 more. And those symbols are A, B, C, D, E, and F. Now the interesting thing about this, A, B, C, D, E, and F actually represent numbers. So what I mean by that is A is actually representative of 10, B is representative of 11, 12 for C, 13 for D, 14 for E, and 15 for F. Now, if you add up all the way from 0 to 9 and those letters, you have 16 symbols that you can use. All right. So what I generally do when I start converting to hexadecimal is I start with my decimal number here. So let's just start with something nice and simple like 41, base 10. I take that to binary first of all, okay? Because binary is a nice little intermediate between the two. And you've got to remember that the initial purpose of hexadecimal was to shorten binary strings down. Okay? And I'll show you what I mean by that in a very quick moment. But let's convert 41 into binary. So I'm going to do it the long way the first time. The rest of the examples, I'm going to do it the short way. And anyway, so that's 20, remainder 1. And then let's go 20 divided by 2, so it's 10, remainder 0. And we've got 10 divided by 2 is 5, remainder 0. 5 divided by 2 is 2, remainder 1. 2 divided by 2 is 1, remainder 0. And then 1 divided by 2 is our stopping condition because it's remainder 1. That means we're left with 1, 0, 1, 0, 0, 1 as our binary. So 41 is this binary. Okay, I'm going to get rid of that underline for a second because it's going to stuff me up. So what I do now when I convert to hexadecimal, so what I do is I group the binary in 4 bits. Okay, another word for that is a nibble. In this particular case, I've got from this one over to this one here. Okay, and then I've got this one over to this one. I've run out of bits, but that's fine. Okay, now I've got them grouped up. I actually treat them as little binary strings, individual ones. So I've got 1, 2, 4, and 8 for that binary string, and then I've got 1 and 2 for that binary string. Now, I'm going to treat them separately the whole time we do this now. So if I add that one up, I've just got 2. If I add this one up over here, I've got 9. What you're actually left with there, 2 and 9, is the hexadecimal version of 41. I wanted to do a therefore, you'd say therefore 41 base 10 equals 29 base 16. Now I said 29 because technically this isn't 29. This is a bigger number than 29, obviously. Okay, so I say 29 in this particular case. All right, moving along, using a bit of a bigger example, let's do 313. Just a quick example. Now, I'm going to be a little bit lazy here, and I'm simply going to bump it into my calculator just so I've got the binary. So I don't want to sit there and do all the divisions. We've got 1, 0, 0, 1, 1, 1, 0, 0, 1. Okay. So once you've got the binary of your number, group it in 4s like I sort of already have. You can see we've got 3 groups now, so we should end up with 3 binary numbers. So not binary, hexadecimal numbers. 2, 4, 8, 1, 2, 4, 8, 1. So in this particular case, if I add them up, I've got 1 there, I've got 3 there, and I've got 9 there. That means my hexadecimal is 1, 3, 9, base 16. Okay, nice and simple in that particular case. So let's make things a little bit harder and let's actually get some letters in there. Okay, so let's go with the number, yep, there we go, 175. Okay, I'm going to cheat again. I'm just going to go straight to the binary, which is 1, 0, 1, 0, 1, 1, 1, 1. Okay, again, I've already grouped them up, but I'm just going to write the lines anyway because I like to. Treat them as their own individual ones. So we have 1, 2, 4, 8, 1, 2, 4, 8. Add them all together. This one here is 10. Now, there we go. There's something interesting. And this one over here, if you add them all together, is 15. Okay. Just as I said at the very, very beginning, we have letters to represent these numbers here. And if you remember the letters, 10 is actually A, and 15 is actually F. Okay, and that's how your letters come into hexadecimal there. Now, one final example before I leave it be and we move on to the next video, which is going to be obviously converting from one to the other. Okay, let's do a pretty big number this time around. Let's do, move along, 3076. Again, going to cheat. 110000000100. Okay, I've already got the binary for it. Group them in fours, like we did before. Add them up. So 1, 2, 4, 8. 1, 2, and I'm still going to do this one. I know it's zeros. 1, 2, 4, 8. Okay, so this first one here is 12. In that case, we've then got 0 for this one. And then you've got 4 on the very end. So 12, if you can remember the letter there, is C. Now, you don't ever get rid of the zeros. The zeros stay in there. So I'm going to put a 0 in between them. And then 4 is just 4. So there we go. C04 is the hexadecimal value for 3076. Okay. So that's for this video, guys. Hopefully that made sense and you can now convert your decimal numbers into hexadecimal.